It's such an honour to welcome Professor David Nutt to give. He's one of only two people to give two colloquia. So the other one's Christine. But yeah, Dave is the Edmund J. Safra Professor of Neuropsychopharmacology at Imperial College London. Is that correct?
Very good.
And he doesn't need much introduction, really. He's had a long and very illustrious career and done all sorts of things. He also leads Drug Science, a charity aimed at developing evidence-based drug policy and promoting that, which I'm very lucky to be a part. He's also done all sorts of things throughout his career. Being chair of the British Neuroscience Association, ECMP, there's a lot of them anyway.
Too many.
And has an almost encyclopedic knowledge of, encyclopedic, I would say, of drugs, as we've just been learning in a meeting with Alex. And I guess, so you can read about all of his work online. It's incredible. Something that probably isn't online about you, I guess. That sounds worrying.
Hang on. What's coming?
No, it's just what an incredible mentor Dave is to a great number of people, and he's an incredible support and champion of all sorts of people at different career levels, like my own mentor Val Curran. So yeah, and that's something that really inspires me, actually, having worked with you for a number of years. So anyway, without further ado, I'll hand you over to Professor David Nutt to talk about 20 learnings from psychedelic.
Yeah, thank you very much. You're right. Can you hear me all right? Yeah, I suppose this, does that work? A little squiggle. Okay, so before I kick off my talk, I'm going to show you this this slide. And those of you who are any of you here interested in psychedelics? That's good start. Good start. So take a photo, please, and I'm going to show it at the end. So this is a new initiative that we've set up, trying to essentially redress the imbalance in attitudes to psychedelics, particularly in places like the Home Office and the government. The research that we've been doing and you're doing down here is severely hampered by the absurd status of these drugs, the Schedule 1 status, the Class A status. It takes us 2 years to get approval to pretty much to do anything. Triples or quadruples the cost of doing this research, and but essentially is damaging to not just to UK research, but also to many patients who'd benefit from, almost certainly benefit from innovation. So take a picture of this, please sign up, and I'll put it up at the end. So if you haven't got your phones ready now, you can have them later. Thank you. So the original talk was 20 years of psychedelic research, 20 learnings, but the field is moving very fast. So now it's 21 learnings. I'll let you guess which the one that was added in at the last minute. How many of you have read this book? Don't you make it compulsory on the course here? Jesus, where? This one, I don't suppose any of you have read this one, but because it's really, really ridiculously expensive. But is it in your library? Good. Well, steal it. Okay. So yes. So what's the first learning? Well, the first learning is that there's been quite a systematic attempt to reappraise the harms of a range of drugs used recreationally by a number of expert groups. This is obviously the one that we kicked off, my charity, Drug Science, kicked off, published in 2010. And this was actually my most cited paper. It spurred the European Department of Justice to fund another study by European experts, which was published here. And subsequently, Australian experts, New Zealand experts and US experts and Canadian experts have all used this multi-criteria decision assessment approach to determine the comparative harms of these drugs. And in the red circles are the drugs we're talking about today. They're psychedelics like psilocybin or mushrooms, LSD, and MDMA. And you can see that the red circles are here. The size of the bar reflects harm. The blue bars or the top bars reflect the harm to the user. The lower bars reflect harm to society. And you can see that even when used recreationally, psychedelics and MDMA are amongst the least harmful of recreational drugs. And when they're used clinically in research settings, maybe only once or twice in someone's life for therapy, they are remarkably safe, much safer than most of the other drugs we might use in medicine. So we know that the hysteria that got these drugs banned wasn't based on any evidence of harm. And that makes the 1960s and ultimately the 1971 ban of psychedelics the worst censorship of research and clinical treatment in the history of the world. And this graph here shows the explosion of research citations for LSD and psilocybin in pink, which came from the discovery, 1940s, and then the making available of the, particularly of LSD, to researchers all over the world. And then the US banned them in 67, we banned them in 68, the UN banned them in 71. And there's almost a complete termination of research. There were 2 years here when not a single citation of psilocybin. And that was the ambition. The ambition of the ban was to eliminate all knowledge of these drugs because they were deemed too dangerous to the status quo. This was the most threatening image that psychedelics were associated with. This is an anti-Vietnam War protest. The American government couldn't ban war protests, unlike our government, but they tried to ban, or they could ban, the drug that they thought was provoking the war protests, acid. And that was just anathema to the government at that time, and that was also anathema to many governments around the world. It wasn't just the fact that they were being used by anti-war protests, it was also about the fact they were changing everything. They were changing art and culture and music, and they were threatening to destabilize the whole establishment. And they were put into Schedule 1 maliciously. Because Schedule 1 says they had no medical use, when up till that point there were 1,000 papers published showing they had medical use. In fact, they were the first true treatments in psychiatry, predating antipsychotics and antidepressants. They were said to be highly dangerous when 40,000 patients were treated with very little evidence of any dangers at all. And they were said to be addictive when there were papers showing that they were anti-addictive. So this was a deliberate, it was an act, as I say, to try to eliminate knowledge of these drugs and to protect the establishment from people who took them and then decided they didn't want the establishment. And I've been saying this for a very long time, but just last week, 3 Swedish people, I'm not sure where Damon's from, but I think certainly 3 Swedes published this paper. This is a remarkable paper. They went back to the United Nations and they trawled through all the documentation that led up to the 1971 ban. And that was a really massive thing to do. And they discovered something that I didn't know. They discovered that the bad guys weren't the Americans. The really bad guys were the French and the Russians. The French and the Russians wanted these drugs not to be banned totally. The Americans said, well, we should allow them in plant form for indigenous use, because of course under the US Constitution by that time the use of peyote for indigenous religious ceremonies was allowed, and they said we should still be allowed to research them. But the Russians and the French tried to eliminate them, and thankfully the Americans held out, so they weren't banned completely, which is why we are still allowed to research them, but we have to research them under that Schedule 1 status. The second learning, which has developed in the last 30 years, is that the pharmacology of these drugs has become well established. We know that they all bind to the serotonin 5-HT2A receptor. They're all agonists, they stimulate the receptor. We know that their potency is determined by their affinity at the receptor. Highly potent drugs like LSD, high affinity; low potency drugs like mescaline, low affinity. And there's a remarkable coherence between their potency and their affinity, which tells us they all work at this receptor. The receptor's cloned, it's a G protein link receptor. There's the binding site. And we know that many drugs which are used clinically today, like risperidone, mirtazapine, block the effects because they block the 2A receptor. So their pharmacology is now well established. And we've also since discovered the 5-HT2A receptor does have a rather special place in the human brain. This is a heat map using a PET tracer that we use. In fact, we developed between Imperial and the Copenhagen PET group. This is an M-bomb. It's a psychedelic agonist, CMB36. It binds to the active site of the receptor, so it only measures receptors which are functioning. And you can see the distribution in the human brain here. Very low density of the receptors here in the spine, in the brain stem, and in the midbrain. And that's why psychedelics are extraordinarily safe. They don't cause respiratory depression. They have very little effect on cardiovascular function or any other fundamental physical function. There's relatively low density in areas of the brain which are old, areas like the sensory motor cortex, the visual cortex. Psychedelics don't inhibit your ability to walk. They don't actually inhibit your ability to see. They change what you think you're seeing, but they don't really change what you are seeing. The highest density of these receptors are in these areas, the frontal and posterior cingulate regions. And on this side, this is a heat map of the evolution of the human brain. And you can see there's a remarkable coincidence between the density of these receptors and the evolution of the brain. These recently evolved parts of the brain are the parts of the brain which make us human. This is where we do our thinking, our analysis, our planning, our decision-making, etc. Now, a couple of years ago, we wrote this paper suggesting maybe it's these receptors which kind of have facilitated or patterned the development of this massive evolution of the human brain in these frontal and cingulate regions. We call these the transmodal cortices. They're the parts of the brain which essentially communicate the human qualities that we have that other primates and other animals don't have. We can't prove that these receptors have a critical role, at least in the evolution of the brain. And McKenna could be right, but we can't prove that. But what we can say categorically is that psychedelics have their primary impact on the parts of the brain which are peculiarly human. And that's actually a very good reason why studying humans with psychedelics is probably preferable to studying rodents. That's another story. The third learning is that the synaptic pharmacology of psychedelics, including ketamine and scopolamine, which also produce psychedelic-like experiences, are very similar. And that's because of the convergence on pyramidal cells, the layer 5 pyramidal cells in the cortex, which are glutamatergic neurons. All these three kinds of drugs depolarize these pyramidal cells. And these are the cells which produce the cross-connectivity of the brain, both the old brain and the new brain. And by stimulating the receptors on the serotonergic receptors that are on those neurons, or by disinhibiting the GABA interneurons which keep them under control, which is what scopolamine and ketamine do, you powerfully depolarize these neurons and so change the electrical activity of the brain. You change the excitatory inhibitory balance, and that then leads to greater excitation. And that acute effect is the psychedelic state. And subsequently, there are other changes, which we commonly now call neuroplasticity, which follow on from the increased activity during the course of the trip. The fourth learning is that Aldous Huxley was right. Aldous Huxley, as you know, was a bit cynical about drugs. He wrote A Brave New World. He recreated an ancient Indian Hindu drug called soma, and used it to control. It was used to control the underlings, the drones in his novel. That drug soma, we've now realised, was called alcohol in modern day, and that's why he was rather cynical about it. And then he took peyote, mescaline, and he thought differently. And he turned to the writings of the English mystic and philosopher and writer and painter William Blake, who wrote this several hundred years before. If the doors of perception were cleansed, everything would appear to man as it is infinite. A man has closed himself up till he sees all things through narrow chinks of his cavern. And that's why the first book by Huxley was called, on psychedelics, was called The Doors of Perception. And that's why, by the way, that's why the rock band The Doors was also called The Doors. And what was interesting about Huxley, he was the half-brother of the other Huxley, who got the Nobel Prize in medicine in 1960 for discovering how the nerve action potential was generated. And Huxley, Aldous Huxley, was very scientifically inclined, but he wanted to be a doctor, but he had very severe problems with his cornea, so he couldn't see very well, which is why he's often shown wearing pebble glasses. And so he turned rather from medicine to literature, and he studied English literature at Oxford. And that's why he knew about the writings of Blake. And then he thought, and I think it's one of the great insights that justifies what you might call self-experimentation. He reasoned that if peyote had opened up his mind, opened up the doors of perception, something must have closed it. And on reflection, he came to the conclusion that what has closed his mind was his brain. And he said this: the brain is an instrument of focusing the mind, a reducing valve. And that is, I think, absolutely clearly brilliant insight. And psychedelics open up the valve. And some of the work that we and others have done show that Huxley was exactly right. And so I want to just talk you through that for those of you who aren't so particularly familiar with the way in which we see or think or hear things. But let's just do vision. You hopefully all know that your brain is not a camera. If you were taking pictures, as some of you are, and that's fine, because your camera can probably hold more than your brain, you'd fill up your memory banks before you could even say the word camera or picture. Now, what happens is that photons come from the environment, they go into your retina turns them into a whole series of multiplex electrical impulses, which travel up the optic nerve into a large chunk of the back of the brain, which produces the sense of vision that we have. And different parts of the back of the brain interpret different elements of what the outside world is and create a percept, which is, at present, looking at me, is me. What your brain creates is then compared with what your brain anticipates creating. So most of you, any of you seen me before, would have come here and thought, well, he's lost a bit of weight, but apart from that, he's the same person. Most of what you see is what you expect to see. Those expectations are called priors, and they're based on years and years of learning about the world. And that's what makes your brain so ridiculously efficient, because mostly whatever goes on is something you've already anticipated. But under psychedelics, the brain's not as good at doing that as it was before, because those layer 5 pyramidal cells, which pull together billions of neurons in your visual cortex, maybe 30 billion neurons building up the image that you have in your brain, they can't do it as efficiently because those layer 5 pyramidal cells are disrupted. And that leads to these hallucinations, these very simple hallucinations. And people say, well, they're boring, they're just Christmas tree lights, However, they're actually really important because those are the primary workings of your visual cortex. We know from the work of people like Hubel and Wiesel 40 years ago that is how the visual cortex works. The impulses coming in up the optic nerve are then structured into simple shapes, colors, and movement. And I think that is actually quite remarkable. So the only time you were seeing images like that when you were a baby. You gradually acquire the ability to turn them into full-formed images. But under psychedelics, you can go back and seeing just how your visual cortex is beginning to build up the wonderful complexity that your visual system produces. And if that's all we discovered, I'd have been happy, but we've done more. The fifth learning is that psychedelics have very unique effects on the MEG, magnetoencephalography, and EEG. MEG is just a slightly more sophisticated, a slightly better resolution form of EEG. But when we use it, and this is work we did in Cardiff University with Suresh, and here you see we measure the same frequencies as you measure in EEG, low frequencies to very high frequencies. And these are brain prints. They show the fundamental differences between drugs like psychedelics. Here you have ketamine, psilocybin, and LSD, and all sorts of other drugs I'll come to in a minute. Blue means less power, and red means more power. And psychedelics produce changes in the brain with significantly less power across particularly these low frequency ranges. And this is a desynchronization of brain activity, which we have called the entropic brain. On the other side, you see drugs which increase the power in certain frequencies. They synchronize brain activity. These are drugs like the sleeping pill, zolpidem, the GABA drug, gaboxidol, the extrasynaptic GABA agonist, gaboxidol, the GABA uptake blocker, tiagabine, the anesthetic propofol, and also alcohol and the glutamate AMPA antagonist, perampanel, the anticonvulsant. This is a fundamental different kind of brain functioning. If you synchronize the brain, your brain is less capable of doing anything. In fact, in this particular study under tiagabine, several of our volunteers became cataleptic. They couldn't move. Because in order to move your arms, you've got to change the function in your motor cortex. If your motor cortex is just churning through these powerful, slow rhythms, you can't move. It's like having petit mal epilepsy. And of course, this is an anesthetic. And if your brain is solid in this high frequency, you don't even have consciousness. So these are fundamental different states. This is a state of less flexibility, less use, less information transfer. This is more flexible, more information transfer. And one of the pleasures of working with MEG is that the time resolution of MEG is much greater than fMRI. This is analysis which was done by Carl Friston and his Rosalind Franklin, his group, and they tested this model. They had a model of cortical oscillation comprising two pyramidal cells, a superficial and a deep pyramidal cell, and two GABA interneurons. And they tested the theory with our data. This is data from psilocybin. So here's the impact of psilocybin across the frequency range. The dominant frequency in the brain is usually the alpha frequency. Psychedelics, psilocybin, massively reduce the power that's in the alpha range. Placebo has no effect. So the change in alpha power was modeled or put into a model where there were four possible explanations or four possible outputs of this little simple circuit. And it turned out that the target of psilocybin in this model was these deep pyramidal cells. This model, psilocybin working here, it gives the best explanation of the changes in frequency we saw. And that's obviously very pleasing because that's where we predicted the effect would be, because that's where more of the 5-HT2A receptors are. There's also, I think, the first demonstration in humans of a drug working on a specific receptor on a particular brain region having a particular effect. And I see there's an EEG expert in the room, and if he's going to disagree, do it afterwards, will you? Sorry about the loss of the top line there, but the increased entropy of the brain leads to another fascinating discovery, this was data produced by Professor Expert's group at King's College in London. And they looked at connectivity in the brain under psilocybin here and under placebo here. This is what we call the small world brain. Your brain is 10 times more energy efficient at transferring information than the best human computers. And that is because most of the processing is done very locally. Visual cortex talks to visual cortex, auditory cortex to auditory cortex. If you hear a bus bearing down on you, you better get your auditory cortex telling your motor cortex to move your legs, otherwise you'll get run over. Because the human brain is so enormous in relation to the size of neurons, the energy cost of communicating across the whole brain is actually really very high. So the brain has become fantastically efficient at processing with minimal energy, which is great. So every word I have said, you've understood. You might not have understood all the concepts, but every time you learn a word, it becomes deeply entrenched. In fact, it's almost impossible to unlearn the meaning of a word. And that's true of many, many memories. But suppose you learn something that's wrong. Suppose you're abused as a child and you're told you're worthless. And every time you see your parent who tells you you're worthless, they keep telling you, every time you think about yourself, you believe you're worthless. You can deeply entrenched a belief that isn't true, but is unshakable, is deeply ingrained. And that's what depression is. Depression is called depression, not no mood, because it's as if you're in a hole and you can't get out. You can't change the way you think. And getting people out of depression is very difficult, as I've discovered in 40 years of being a psychiatrist, because the thoughts can be very entrenched. And the same is obviously true of many other psychiatric disorders. The only way we can disturb the brain adequately to change the depth of processing, particularly of emotions, is a psychedelic. Psilocybin massively increases, and so do other psychedelics, the connectivity of the brain because of this fundamental perturbation of the activity through those layer 5 pyramidal cells. The brain goes back to being connected as it was when you were a child. And one of the explanations of education, one of the targets of education is take a brain in which everything's possible and drive it into a brain where everything is actually predictable. That's the old Jesuit belief. You know, give me a child at 7 and we'll make sure they believe the same things for the rest of their life. Psychedelics undermine that entrenched learning. They change the way people think about themselves, the way they think about the world and their governments, but they all can also change the way they think about negative thoughts. This is a beautiful image by this man here. Leon, put your hand up. He did this study. This is the world's first ever image of LSD in the brain. And it's a beautifully clever study because before he scanned these people, he worked out where the V1, the primary visual cortex was in the volunteers. So this is the magenta bits here. And then he looked at connectivity under placebo and under LSD. But this is the small world brain. Almost all the visual processing you're doing now is happening just locally to your V1 primary visual cortex. A little bit in the movement area, a little bit in the hippocampus to make sure you remember anything interesting you see. But mostly it's a small world. Under LSD, the V1 is connected to everywhere in the brain, which is why people have these powerful, enormously complex and interesting visions like dreams of a repeated, duration. And it's also why you get phenomena like synesthesia, why you can smell colors and other sort of hyperconnectivity as well. So I've already intimated this, but the great clinical learning that we've had in the last 20 years is that we can use psychedelics to change the brain mechanisms underpinning depression. And that's it. Why is that important? Well, it's important because depression is the leading cause of disability in the Western world now. Treatments fail in about a third of people, and there's an increased prevalence in young people. Now, when we started out working in this field, I was working with Robin Carhart-Harris, who was a postdoc at the time, and Leor, who was a PhD student. And our interest is in what was the psychedelic state. Because by that time, I'd been working in the field for 35 years. I'd actually studied in humans almost every kind of drug you could give to humans. But never psychedelics. Why? Because, well, they're illegal and they're difficult. I studied serotonin receptor antagonists. They're actually surprisingly uninteresting. But Robin and a woman called Amanda Fielding persuaded me it was time to be brave. So we started the psychedelic research. I got sacked as the government's chief drug advisor as a consequence, but it was worth it. When we started, we assumed that the visual experiences that you get under psychedelics would be produced in the same way as studies up till then with delirium had shown, which was increased activity in the visual cortex. When we did the first imaging studies with psilocybin, and these are two separate studies, one using ASL, arterial spin labeling, one using bold. This is the bold image. There was nothing. There was no activity in the visual cortex, because essentially you were switching off the ability of the visual cortex to create images. So that's why you see those primary elementary hallucinations. What we found was overall psilocybin attenuated activity in the brain, particularly in this brain region here, which is called the medial prefrontal cortex. Now that was an area we had been very interested in for a very long time, because going back over a decade before this work, various groups had shown that antidepressants of different sorts, SSRIs, cognitive behavior therapy, sleep deprivation, ECT, dampened activity in this brain region as people got better. In fact, Helen Mayberg showed that if you get better on placebo, this region shows less activity. And that's why she developed deep brain stimulation, put electrodes into here, switched it off, and people's mood lifted. And subsequently, Bill Deakin had shown that ketamine did the same. So we knew by the time we'd done this study, multiple different antidepressant treatments attenuated activity here. And we thought, well, CBT might take 3 months to do this, and SSRIs will take 6 to 12 weeks, but we could do it in the space of 30 minutes. And when people came out of the scanner, they often said they felt better, they felt more alive, they felt happier, more in tune with the world. We thought, well, maybe psilocybin would be antidepressant. And the second reason was because of this discovery, which is essentially the core of the psychedelic experience, which is that psychedelics completely disrupt the network in the brain called the default mode network. Now, this is a network, it's called the default mode network because that's a network in which you code your sense of self. When you're sitting quietly with your eyes closed and you're not listening to anything and you're just thinking about yourself, your past, your present, your future, the dominant network is the default mode network. And you'll remember from the original slide I showed you of the evolution of the brain that this network is the transmodal cortex. It's the most recently evolved chunk of the brain. So we're switching off the part of the brain in which humans do the very high level human thinking. Psychedelics completely disrupt that network. That is what the psychedelic state is in essence. It's a complete disruption of the way you normally think, and so you can think differently. What's that got to do with depression? Well, just before we did that work, this group at Yale had shown that people with major depressive disorder, MDD, in that population, a greater proportion of the brain was engaged in the default mode network. The network was bigger compared with healthy controls. And that in itself is a fascinating finding because it explains why depressed people struggle with executive tasks, why they struggle to read or watch a film or go to work, because so much of their brain is consumed with this internal thinking with a negative connotation that they've got less resources to do more executive tasks. The driver for this hyperconnectivity is the subgenual region I showed you before. And there's a strong relationship between the hyperconnectivity and rumination. And what do depressed people do? They ruminate continually about their failings, their inadequacies. They have guilt about what they've done to other people, etc. Even though they know they're not guilty, they have those thoughts which they can't break because they become deeply entrenched. So we thought, well, too much default mode is bad. Get rid of it with psilocybin for a couple of hours, 5 hours might be good. So we did the depression study. And this is the next learning, was that study was done. It was started in 2012, finished in 2015. All the people here had failed on at least 2 antidepressants. Some had failed on more than 10. They'd all failed on CBT. These were the depression scores before. And a week later, it was probably occurred a day later, but we didn't think it would be fast, but it was. Depression scores went right down. We halved depression scores. The depression scores continued to be low for up to 3 months. And that's the most powerful single intervention in resistant depression there's ever been. And it's spawned at least 40 different companies now developing products, psilocybin, variants of psilocybin, DMT, variants of DMT, LSD, other mescaline, to try to replicate that. And many of them have. Over here, a few years after, Balazs Seghetti in our group did a Bayesian analysis. So this is a sort of a classic statistical analysis. This is the Bayesian analysis. And even if you're skeptical about the likelihood of it working, the next patient going into a study like this would have over a 70% chance of getting better. So it was a really remarkable finding. And there have been multiple replications. There's a massive US multi-center study. There's a within single center study, Johns Hopkins. This is a very famous, now perhaps the most important of all the studies. This is the Compass Pathway study, which not only replicated with a 25 milligram dose of psilocybin, our findings, but showed it was dose related. A 10 milligram dose and a 1 milligram dose had much less effect. And this is a study that was published 2 days ago, the German study, which is one of the other ones that have been done. This is the most recent one I thought you'd be interested in. It's a very complicated study. It's too complicated, unfortunately, because it was a bit underpowered for that reason. But nevertheless, it showed quite clearly that a 25 milligram dose of psilocybin was significantly better than a 5 milligram dose, significantly better than placebo. And the 5 milligram dose, after a period of, this is 3 weeks, I think, you gave them a bigger dose and they got better. So we've got multiple replications in at least 5 different countries now. And it's not just psilocybin. These are studies some of these studies here use ayahuasca, some use LSD. And this is another very recent study from David Nutt and our team, who designed the study for a company called Small Pharma, now owned by Cybin, which is the first DMT depression study. And DMT is obviously a very different drug to psilocybin. We have to give it intravenously. It gives about a 30-minute trip as opposed to a 4 or 5 hour trip with psilocybin. But you can see here that the DMT infusion massively reduced depression scores. The saline infusion didn't. And then at this point, the group that hadn't had the placebo then got DMT, and they did very well. And the group that got DMT carried on having DMT, had another DMT, and they carried on doing well. Although interestingly, it's not significant, but it looked like the second dose of DMT wasn't as effective as the first, probably because of a floor effect. So you can have short-acting ones, you can have longer-acting ones, they lift depression. And this is work from, this is Lior Roseman's study from our first depression trial. One of the critical questions is, well, does a psychedelic experience matter? And if it does, which bits of it matter? So here are the different ratings of the different experiences of people in that first study. And Leo broke them down into people who did very well and people who didn't do so well. And what he showed was that people who didn't do so well were ones who were anxious. Anxiety is a bad thing if you're having a trip, as I guess most people would have imagined beforehand. But more importantly, in a way, he showed that what we now call the powerful experiences of unity, of spirituality, of bliss and insight, these were the ones which were greater in those who had good outcomes compared with those who didn't have such good outcomes. So psychological experience, particularly this very sort of high order psychological experience, more than say synesthesia or elementary imagery hallucinations, these are what predicted good outcome. That's been replicated in a study I'm going to show you in a minute, now psilocybin, it's the citalopram trial. It's been replicated in the Compass Pathway trial and also replicated in the DMT trial last week. So this looks at even a short trip, even a 30-minute trip. The meaning has some value. So this is a breakdown of changes in the Montgomery-Asberg Depression Rating Scale. Less is better. The people who had high levels of mystical experience, that group, did better than those who had lower levels of mystical experience. So we've now got quite a lot of data suggesting that the conscious experience has some added benefit to the psychedelic state generally. Learning 11, this is the only, still amazing after 15 years, the only comparative study of a psychedelic and a conventional treatment, the SSRI. Very difficult studies to do, hugely challenging. We did it thanks to efforts of an amazing team. So it's basically a head-to-head. Escitalopram is the leading SSRI in terms of selectivity, very popular drug, very commonly used drug. I won't go through it in detail, but in essence, people were randomized to either 2 doses of a trip with psilocybin or 2 doses of a very low dose of psilocybin, a non-trip dose, placebo. And then the trip people got placebo and the non-trip people got escitalopram for 8 weeks. And you can see the depression scores that the psilocybin group outperformed the escitalopram group across the course of the 6 weeks. Escitalopram did rather well because there was a lot of psychotherapy here and here. The second dose didn't have a great deal of effect. Again, this could be a floor effect. And it's generally found now that the second doses don't work unless people are relapsing. But what was remarkable about this study, and very unexpected, was that if you don't, this is just looking at mean change in a depression rate, self-rating score. If you look at both self-rating scores and doctor rating scores, in terms of remission, getting people from a state where they're into a state where they effectively do not have depression, where they're able to work, go live a normal functional life. The actual scores, which meet the criteria for remission, vary enormously on these different scales, and we don't fully understand why that is, but it doesn't matter. Whatever scale you use, between 3 and 4 times more people meet the criteria of remission if they were given psilocybin than if they were given escitalopram. And that remission is what we are targeting. So that's a really powerful finding. Why does it happen? Well, one of the reasons it happens is because this is bigger, depression scores go down more. Another reason you get better remission rates is shown on this side of the graphs. So this is well-being. This is the Warwick-Edinburgh Mental Wellbeing Scale. And well-being is the kind of obverse of depression. And lifting depression is good, but improving well-being adds to the antidepressant effect, and it gives you resilience. And you see here that psilocybin profoundly increases well-being, the first dose, and that persists in the second dose, may help a bit more. Escitalopram improves well-being, and that's what you'd expect. Lifting depression would improve well-being, but it doesn't improve well-being as much. And that's because escitalopram has adverse effects, many more adverse effects than escitalopram, because you take escitalopram every day, you take psilocybin twice. So that combination of more well-being and less depression gives you better outcomes. And that study was actually, it wasn't a clinical trial to compare efficacy across the 2 drugs. It wasn't really powered for that. It was quite remarkable that we found a significance at all. What it was powered for, we're asking the question, what are the brain mechanisms? Are there different brain mechanisms between an SSRI and psilocybin? Or is it just that psilocybin does the same but faster? And we looked at the brain mechanisms using 2 separate imaging paradigms. This one is looking at the flexibility of the brain, the modularity of the brain after psilocybin and after escitalopram. Modularity is a measure of the inability of your brain to change what it's doing. It's a measure of how fixed your brain is in terms of the routines it's running. And what you see here is that psilocybin, this is 3 weeks after the second dose, significantly reduced modularity. The brain became more flexible. And that correlated quite well with what our patients tell us. Patients tell us after the psilocybin, they can think differently. And if a depressive thought comes into their mind, they're able to put it away. They're able to change their thinking away from depression to something positive. That increased flexibility, reduced modularity, strongly correlated with outcome, and it was associated with increased connectivity, particularly of the executive network, which is what people say when they're better on after psilocybin. They can think more clearly, and they can do other things. Then they can read books, they can solve puzzles, etc. Go to work. Escitalopram did not change the flexibility, and so there was no relationship there. So how does escitalopram work? Well, we tested the prevailing theory at the time, which is, I think is still true, that SSRIs and other antidepressants work in a different part of the brain. They work in the amygdala. The amygdala is the fear center of the brain. Here you see these little blobs here. There's the amygdala. And for the last 30 years, we have known that if you put someone in an MRI scanner and you show them someone who's frightened with a fearful face, the amygdala becomes activated. So we wanted to test the theory that escitalopram would work by suppressing the activation to a fearful face, which has been shown by many, many studies. In fact, there's so many studies, there's even a meta-analysis 10 years ago on the impact of antidepressants on the amygdala. And the amygdala, this is white cold. The amygdala, the switching off the amygdala response to fearful faces is an enormously reliable finding in neuroscience. But again, we were interested, and particularly Lior was interested in, well, what happens to happy faces? What about neutral faces? Does psilocybin switch off fearful faces? Does it do anything to these? So he designed this paradigm where the people got all three exposures, and this is the results. It was really quite very compelling. So the top image here is a comparison of psilocybin and escitalopram groups during the exposure to all the faces. And what this image shows is that under psilocybin, there's much more activity in the brain when you see a face. And that's kind of good, because we spent most of our life looking at other people's faces, and depressed people don't get much pleasure from looking at other people's faces. After psilocybin, there's increased activity across this very large brain region. When we dig deep into the amygdala and look at the responses to the facial images, you see exactly as predicted with escitalopram. Escitalopram blunts the response to all faces. It blunts the response to fearful faces. It blunts the response to happy faces, and it blunts the response to neutral faces. And this blunting is a problem, because many people on SSRI say, yeah, I'm no longer fearful. I'm no longer depressed. I don't feel negative emotions, but I don't feel positive emotions either, because escitalopram blunts that. And psilocybin didn't blunt anything, and it might have even made people a bit more interested, or a bit more activity in happy faces. So that shows a fundamentally different way in which these two drugs work. One, escitalopram targets the limbic system, dampens it down, whereas psilocybin works in the cortex and has little effect subcortically. Another learning, which is enormously important, and because it's a subject of phenomenal antipathy to to psychedelics, is the supposition that people only get better because they expect to get better. To my mind, is an actually insult to patients. I mean, it truly is. It's a sign of enormous prejudice against mental illness. But we tested it. So this was Balazs Ligeti's data. We asked people before the first dose of psilocybin whether they thought it would work. We asked them before the second dose of psilocybin, and if they're going to work. We asked them, would escitalopram work before the first and second. Expectations were very different. The majority of people, the expectation scores were higher for psilocybin than for escitalopram before they had the treatment. But afterwards, expectation, when we look back, expectation had no impact, the pink bars, had no impact whatsoever on the response to psilocybin. It actually had a significant impact on the response to escitalopram. If you don't think an antidepressant is going to work, it probably won't. But psychedelic psilocybin worked whether you thought it was going to work or you had high expectations or not, which is really interesting because it tells us that in a way expectations can be also, low expectations can be disrupted by psilocybin. So the next learning then is we have two ways to treat depression. We have the traditional way, conventional antidepressants, mostly working on the serotonin system. They enhance serotonin in the limbic system here. That stimulates a serotonin 5-HT1A receptor. It's an inhibitory receptor that dampens down limbic activity, reduces anxiety, reduces impulsivity and aggression. SSRIs have these powerful effects across a range of different symptoms. They reduce stress responsiveness. They give you resilience, but they can also give emotional blunting. So the analogy I like to use is that SSRIs are to depression what a plaster of Paris is to a broken bone. The plaster does not heal the bone, but it maintains the bone in a state where it can heal itself. It stops the bone being continually stressed as a result of the fracture. That's why SSRIs take weeks to work, because it takes 4, 6, 8 weeks for the brain to heal itself when you've blunted the stress. Psychedelics works in the cortex, different part of the brain, as does ketamine. They work on a different receptor, this 5-HT receptor, and then downstream a glutamate signaling. They increase cortical entropy. They break down inflexible thinking. They break down perseveration. They give increased cognitive flexibility, and they improve well-being as well as reducing depression. And that's very exciting now. So for the first time in 50 years since we've had antidepressants, our patients have got some options. Other common disorders like cancer, you've got maybe 10 different treatments. You've got hypertension, you've got at least 6. Now we have 2 treatments, which is great. And this is a comment from one of our patients who's had both treatments. Where escitalopram nulled me to be less scared, psilocybin has made me realize that fear is not something to be feared. And I think it's a very telling comparison of the 2 mechanisms. 16, well, psychedelics treat a whole range of disorders: depression, GAD, addiction, anorexia, OCD, fibromyalgia, probably not ADHD. People say that's ridiculous. You know, these are all different diagnoses. They've all got different brain circuits. They've got different neurotransmitters. How can psychedelics do that? And my argument is that they're all internalizing disorders. They're all disorders where rumination is the driving feature, and we can disrupt rumination. And if you disrupt rumination, you basically allow people to escape from the disorder. Here's a couple of data sets that are not yet published. The anorexia one on the left is coming out in the next couple of weeks. This is a remarkable study. These are 20 women with anorexia. They've had it for an average 10 years. And this looks at a rating called the Eating Disorders Examination at 6 months. So and you can see that the treatment here was a placebo, psilocybin, 2 to 25 milligram trips. And you can see over 6 months, there was a very profound reduction in disability related to eating. Over a third of them were in the normal range when you ask this question about your attitude to eating. For a third of those patients, that's transformational. The doctors and the therapists who are specialists in eating disorders say they've never seen that before. Something that can transform the way someone with anorexia actually views their disorder. This is a fibromyalgia study. This is a placebo dose, and then a high dose. Profound reductions in both pain scores and disability scores. And then there's also now data on PTSD. And I was very surprised after Leo's analysis 10 years ago that anxiety was a bad predictor of the outcome to psilocybin in depression. I was always rather hesitant about thinking we could use the psilocybin for trauma, anxiety disorders. But this is a study that Compass did. It's a study, 22 patients, all antidepressant free. They got a dose of psilocybin, and all the scores of trauma reduced, and their disability scores reduced as well, and their quality of life went up. So that's really quite compelling evidence that you can use psilocybin instead of MDMA probably in trauma disorders. And very pleasingly, the quality of the psychedelic experience also predicted good outcomes in PTSD. And I think it's supporting the idea that it isn't just a pharmacological jolt to the brain, it's actually insight and understanding and sort of self-awareness and maybe self-compassion are important to the outcomes too. And also there are studies in addictions. This is a series of studies done by Matt Johnson at Johns Hopkins. Sorry, the slides moved because it's, but anyway, basically of 15 smokers, he got 12 abstinent in over a year using psilocybin. He's done subsequent studies with good outcomes, and NIDA now, National Institute of Drug Abuse in the States, has now funded for the first time in 55 years a psychedelic study to help people stop smoking. And this is the bog and shoot study of drinkers showing very powerful impact of 2 doses of psilocybin to stop people drinking over a course of 6 months. And that's now gone into a phase 3 trial. And it may be that psilocybin will be licensed for alcohol use disorder before it's licensed for depression, although I suspect the COMPASS data will come out first. We've just started a study in abstinent heroin addicts, the first one ever with psilocybin. And also we're looking at people with gambling disorder because there are no drug treatments for gambling. We've also been interested in, do you need a trip? Can you use psychedelics in a different way? And we were forced to do this when we got a grant to study people with OCD. And we talked to our expert patients and said, we think we can disrupt your ruminations about cleanliness, etc., by giving you a trip. And they said, what's a trip? And we explained to them what a trip was, and they said, you must be mad. Don't you understand? We don't want to lose control. We're going to lose control for 5. I mean, come on. So we sort of backed off and we said, okay, well, what would you be prepared to have a dose but without a trip? And they said, yeah. So this is the design: a 1 milligram dose, a completely inactive dose, a 10 milligram dose. And you can see over the course of the next couple of weeks, these scores on the Y box, obsessive compulsive scales went down. And they went down both, whether you were looking at compulsions or obsessions. And now we're writing with you lot in Exeter, with Celia here, a grant to replicate this. But rather than just give 1 dose of 10 milligrams, we're going to give up to 6 doses over the course of 4 to 5 months to see if we can get a bigger effect and a more prolonged effect. Because you see the effect here only lasted a couple of weeks. We're also learning that psychedelics can help neurological disorders. I've showed you the fibromyalgia data. There's now good data on cluster headaches with drugs like psilocybin and 5-MeO-DMT. I'm advising a company that is doing a 6-hour DMT infusion at a sub-psychedelic dose, something we developed in-house, to see if we can use the neuroplasticity of DMT to promote recovery from stroke, to help the cells which aren't dead but can regrow in stroke grow faster. And we've got some interesting data, preclinical data on traumatic brain injury. You'd be pleased, and there's only 2 more, aren't there? 20 and 21. The last ones are about MDMA. It's really important to emphasize that it's not a psychedelic, but it's a useful tool. And 25 years ago, any scientific presentation on MDMA would be about how it was damaging the brain. And now we're talking about it healing the brain. And why is that? Well, it's effectively because of the Afghan and Iraqi wars. You have the situation now where, certainly for United States and Australian soldiers, more kill themselves or kill other soldiers than are killed by the enemy. And that is bothersome to the military. And so they're interested in therapy and in helping people not kill themselves. And of course, there's enormous collateral damage from wars. So the civilian population is heavily traumatized. PTSD is the disorder now of this century. And we know that MDMA can overcome PTSD. And we also know how it works. We know how MDMA helps suppress the emotional memories that recur and impair the ability to engage in treatment. And we know that because of this work that we did, which was the first ever brain imaging study with MDMA, showing that MDMA is not a psychedelic, but it suppresses limbic activity, particularly the amygdala and hippocampus. And by suppressing that activity, people can better relive the memory of the trauma without the emotions breaking through and effectively disrupting their engagement in therapy. And 30 years ago, I started treating people with PTSD, trying to desensitize them, and they would either faint or they'd run out of the room because we didn't have any way of containing their anxieties. And we also know a lot more about MDMA, and this is, I want to really emphasize this point, because that people talk, it's methylene dioxy methamphetamine, which is a really unfortunate name for MDMA, because it's not an amphetamine. It is structurally an amphetamine, but that doesn't mean anything. Functionally, it's not. It's an entactogen. And this shows very clearly the major effect of MDMA on the brain is to release serotonin. Much lower levels are releasing noradrenaline and dopamine. And that's exactly the opposite of what amphetamines do. But we still see hysteria on the FDA. You've got to make sure this drug doesn't cause addiction. Well, it's anti-addictive, we know that. But it releases dopamine. It must be addictive. It's got an amphetamine. So I want to emphasize, not only is it not an amphetamine, it's also not cardiotoxic. We've known for 50 years that increasing serotonin is cardioprotective, as well as potentially anti-addictive. And it's very important we change the narrative on this drug away from it being an amphetamine. And I'm working with a company called Solvonis now, which is developing alternatives to MDMA, which will be legal and hopefully easier to study. And there's one of them. We'll find out soon whether it works. These are the clinical data with MDMA. We've got really good data. The MAPS data in PTSD is very powerful. That's the first of the two Mitchell papers. This is our own study done in Bristol, showing that 2 doses of MDMA in detoxified alcoholics produce really quite significantly reductions in drinking over the next 6 months compared with no treatment as usual. And then the last learning is this, that some countries are more rational than the UK. Unfortunately, I've known that for a very long time, ever since the Dutch brought in their cannabis policy 40 years ago. But the really important change is Australia. Over 2 years ago, the Australian MHRA equivalent, the TGA, rescheduled psilocybin for treatment-resistant depression, MDMA for PTSD. You can read about it here. They did it because they said the evidence is good enough. 700 patients treated. That's more patients than were treated positively with Prozac when that got a license. That's good enough for us. Just because it's not done by a drug company doesn't mean we couldn't use it. The same for MDMA. And in the States, of course, the only thing that the US Senate agrees on is that mushrooms are the future. That's why you have it doesn't matter if it's a red mushroom or a blue mushroom. Yeah. So I'm going to just throw this in because we're working with the Australian site that has done the most work. It's done over 30 patients now with MDMA therapy for complex PTSD. These are the first 15 patients. These are the CAP scores. And you can see all but one had remarkable reductions. This is a massively significant effect. These are people who failed everything. And we're writing up these data, which will be published hopefully in the next few months. So I'll finish now. There's a quote from a philosopher. I'd like to throw him in when Peter's here. Those who cannot change their minds cannot change anything. So what I think we found is that psychedelic treatments change the minds of our patients, as Huxley predicted, through changing their brains. I asked the question, can this research now change the public's mind? I think it already has, frankly. I think the public are on side. The problem are politicians, because it's a much harder mind to change because it's much smaller and very difficult. But we're working on it. I want to say, thanks a lot to the people who supported this work, particularly this trust here. This family lost their son in his mid-20s through suicide, and they gave us his legacy to do the escitalopram trial. And they continue to fund us now. And I'll leave you with that. So hopefully, like any of you were doubting, please sign up and join the cause to change the legislation so we can do this work faster and more cheaply. Thank you.